Materials are used for making objects, and these materials can exist as solid, liquid, and gases, and they actually have different properties and uses. This is Learner's Aid, where scholars are made. From the earliest of human times, we actually depended so much on materials. We depended on different forms of materials like stones, woods, and animal skins. We depended heavily on stones and wood for making tools and shelter. And we also depended on animal skins for making our clothing. This period of time was known as the Stone Age, simply because we depended more on stone than any other materials. But it didn't end there. Along the line, humans actually went ahead to also discover bronze and iron. So that led to the Bronze Age and the Iron Age. But here's the interesting aspect. These materials were far stronger than wood or stone. So they were used for making stronger materials, materials for farming, and those for building and transportation. But along the line, as science also developed and humans developed, we ended up discovering things for glasses, plastics, and rubbers. And this also led to manufacturing things for mobile phones, cars for transportation, and heavier machines for more complex and difficult tasks. So it is clear and obvious that these materials have helped human life develop over the period of time. And human survival and success in this life depended heavily on these raw materials. So the question is, what exactly do we mean by materials? To put it simple, materials are substances that we find in our environment from which objects can be made to satisfy the need of humans. So any raw material that you find in this world, or any raw substance you find in this world, that can be used to manufacture something to solve the need of a man or human is known as a material. And when we say the need of man or humans, we are referring to our need for houses. So there are a lot of raw materials out there that can be used for buildings. We have stones, we have wood, all of these are materials. We also have our need for food. So we need to prepare food. We have raw materials that humans depended so much on for preparing food. And we can also mention wood for setting up fire to prepare our food. Then we have our need for travel. So these raw materials were used to manufacture even the vehicles that we use today. So it is no telling that humans' dependence on material is so huge and then has been dating back from the time of creation. Now, all these things that we have around us, these materials that we have around us, are made up of matter. And what do we mean by matter? Matter is anything that has mass and volume. And when we say volume, we are referring to the space occupied by an object. The space an object occupies is its volume. What that means is, instead of saying matter is anything that has mass and volume, you can also say matter is anything that has mass and occupies space. So in 2018 and 1990, there were these objective test questions that came in BECE, and the question was, the space occupied by matter is its, obviously that is volume. So pay attention to this. Just by knowing the definition of matter, you'll be able to answer this objective test question in BECE or in your final year exams. And then there was also a question in 1992 and 2007 that which of the following properties is true about all matter? And the answer is matter has volume and mass. Matter has volume and mass. So what does that mean? Just by knowing the definition of matter, you should be able to answer this question. And I pray that in your final exam, you'll get questions as simple as this. Good. Now, matter is made up of 3 particles, and these particles are atoms, molecules, and ions. And interestingly, in 2013 and 2017, there were questions from this particular aspect of materials. Now look at this. In 2013, this question came as a section B question that lists the 3 particles that make up matter. And the answer will be atoms, molecules, and ions. But interestingly, 4 years later in 2017, this same question was repurposed into a section A question. Question 21, 2017. It came as an objective test question. So what does that mean? It means that there are certain questions that can just be refined or restructured from section A to section B, or from section B to section A. And for this particular one, you can just be given options like this: which of these particles or which of these materials are particles that make up matter. Yeah, let me put it that way. And you'll be given I, atoms, II, molecules, ions, IV, and something else, and you'll be asked to choose from it. So as we prepare for our final year exam, pay attention to this particular point. No question is unique to section A or to section B. Section A question can be restructured into section B, and section B into section A. So at this point, we've seen the 3 particles that make up matter. But out of these 3 particles that make up matter, atom is considered as the basic unit of matter. So atom, molecules, ions. Atom is considered the basic unit of matter, or the fundamental unit of matter. And then in 2000, the year 2000, BECE, question 3, they were asked to state or choose the basic unit of matter, and the answer is A. So the basic unit of matter is A, atom, B, molecules, B, compound, C, molecules, and D, electrons. There is a possibility when one of the options can be ions. Even with that, don't get confused. Still go for it, atoms, as the answer to the question. Now that we've clarified what matter is, its definitions, and possible exam questions that can come just from the definition of matter, let's look at classifications of matter, or in other words, the states of matter. There are actually 3 states of matter. We have solids, liquids, and gases. For the diagram I have on the screen, the solid is the pot, and then the liquid is the water in the pot, and then the gas is the vapor evaporating as a result of heating the liquid. Now, these classifications of matter depends on these criteria: the shape, the volume, ability to flow, and arrangement of the particles. What does that mean? All the materials that we have in this world, whether to classify it as solid, liquid, or gas, these are the things that were considered. Is it able to flow? What is the volume? Is it having a fixed volume, or its volume is not fixed? What is the shape? Is it having a fixed shape or not? So these were some of the criteria that were considered before placing these materials into either solid, liquid, or gases. Another important thing I want you to pay attention to is, out of these 3 states of matter, solid, liquid, gases, liquid and gases are considered as fluids. So when we say fluids, fluid is a collective name describing what? Liquid and gases. So in the year 2020, an objective test question, question number 35, there was this question that is, which of the following states of matter are fluids? Which of them are fluids? And you were given I, Roman numeral I, solids, liquids, gas, and the answer will be what? Liquid and gases. Now that we've clarified the 3 states of matter, let's pick them one after the other. The first one we'll be considering is solid. So what is a solid, or what are solids? A solid is a material that has a definite shape and a definite volume. What does that mean? When we get to the properties of solid, we'll get to understand what we mean by definite shape and definite volume. There are other textbooks out there that instead of saying a solid is a material that has a definite shape and definite volume, they say a fixed shape and a fixed volume. Is basically the same thing. Fixed shape is the same as definite shape, or fixed volume the same as a definite volume. So what are some properties of solids? Some properties of solid. The first property of solid is that solids have fixed shape. Right from the definition, solids have fixed shape. And then the next one is solids have fixed volume. What do these two properties mean? If you look at the stones that appear on the screen, each of these stones have their unique shape. And this shape is never going to change irrespective of where you place them. Unless otherwise you crack them or you break them into pieces. But their shapes are remaining the same no matter where you find them in this world. And then the volume, which is the space they occupy, are also never going to change. That is why we say these solids have fixed shape and fixed volume. And then solids are not easily compressed. You can't just pick these stones and then squeeze them this way. You can't easily compress them. And the reason you can't easily compress them has to do with the way the particles of these solids are arranged. And we'll see that very soon. Solids also do not flow. Solids do not flow. If you look at the image you have on the screen, that is more like a waterfall. You will see that the mountain is fixed, it's not flowing, but the water is flowing. So you see how water flows? Solids are not able to do that. In other words, instead of saying solids do not flow, you can also say solids have low kinetic energy. Their kinetic energy is low. And when we say kinetic energy being low, that means their ability to move is very, very low. And for the last property I have here, the particles of solids are tightly packed and only vibrate in position. If you look at the diagram we have on the screen, the white circles represent the particles that make up the solid. These particles are very closely arranged. They are tightly packed. Because they are tightly packed, their freedom of movement they do not have. But they can only shake in their fixed position. They can only vibrate or shake. But they can't just be sliding over each other and moving over each other like we see in liquid and gases. So these are some of the properties of solids. What about some examples of solids? I know there are a lot of them that you know, but for the ones that I have on the screen, you have stones, spoon, bricks, plastic chairs. There are a lot out there. Which other examples of solids do you know? You can leave them in the comment section. What about importance of specific solids to life? We have wood for furniture, houses, and firewood. We depend so much on wood when we are building. And then we have stronger solids like iron and steel for tools, building, and bridges. And we have plastics for containers, plastic chairs, school items, and coal. And we also have clay and bricks for building houses. And we also have these clays for ceramics. So there are various uses of solid that we so much depend on as humans. That being so good, let's move on to our next state of matter, that is liquid. What is a liquid, or what are liquids? A liquid is a material that has no fixed shape but fixed volume, or no definite shape but definite volume. If you look at our previous definition for solids, solids have definite shape, definite volume. Liquids have no definite shape but definite volume. We'll get to the explanation of that very soon. And mind you, no definite shape is the same as no fixed shape, but fixed volume or definite volume. So when we get to the properties of liquids, we'll get to understand what you mean by no definition. So what are the properties of liquids? For the first one, liquids have fixed volume. Liquids have fixed volume. And then the second property is they take the shape of their container. Good, let's explain these 2 points side by side. Now, if you look at the bottle that just appeared on the screen, let's assume this bottle is 500 ml. This 500 ml will always be 500 ml, irrespective of where you send it. If you take it from the house to the school, the 500 ml will always be 500 ml. And I'm sure you agree with that. The volume is never ever going to change. Volumes of specific liquids, as long as you measure the volume and you are sure it is 1 liter or 500 ml, no matter the container in which you pour it, it will still be 500 ml. It is assumed that a 500 ml sachet water, which you call pure water, but I don't even know what is pure about it in the first place, 500 ml, sachet 500 ml. Even if you pour it into a cup, it should still be 500 ml. If you pour it into a bottle, it should still be 500 ml. That means the volume is fixed. But one thing that is not fixed is the shape. 500 ml sachet water, if you look at the shape, it's quite different. Transfer it into a bowl, it will be different. Transfer it into a bottle, the shape will be different. What that means is the liquid will take the shape of its container. That's one interesting thing about liquids. They have fixed volume, but their shapes are not fixed. But their shapes depend on the container where they find themselves. So if you look at the bottle we have on the screen, if you transfer the water from the bottle into the glass, the water will not take the shape of the glass. That is why when you put pure water, which we call pure water, sachet water, this into a freezer and it becomes ice block, and you tear off this rubber, the ice block will take the shape of the rubber, as simple as it is. And if you put it in a bottle of water, you put let's say water bottle into freezer and it freezes, you realize the block will take the shape of the container. That's what you mean by liquids taking the shape of their containers. And then liquids are not easily compressed. Liquids are not easily compressed. This is what it means. If you have a liquid in this, and then let's say a bottle, yes, I think bottle would be a best example, and you fill it to the brim and you close it. If you have no gas around it, no empty space, and you try to squeeze that bottle, you see how difficult it will be? What it means is that compressing liquid is not as easy as you think it should be, or it's not as easy as we should have it in gases. So compressing liquid is so difficult. And then liquids are able to flow. Back to our previous example that we used, like the waterfall example, you can see that the water from the top of the hill is flowing downwards. In other words, the water has high kinetic energy. If you have a slightly inclined table and you put maybe a stone on it and then you pour a little water on it, leave these two and go and come and see what will happen. You will see that the liquid will flow downwards, but the stone is likely to remain where it is. What that means is liquids are able to flow, or they have higher kinetic energy. And then for the last property, the particles are close together but can slide past one another. If you remember the particle diagram that I showed you for solid, you can see the particles are really close to each other and there's no room for sliding over each other. But for liquids, yes, they are close together, but still there's some kind of room for interaction. Yes, you move past each other a little, they're able to do that. If you look at the diagram that we have a lot of particles out there, yes, that's true, but there's some room for what? Sliding over each other. That's one interesting thing about the particles of liquids. Let's look at some examples of liquids. We have water, palm oil, milk, honey, petrol. We have a lot of examples out there, which I know you will be able to list them in the comment section. What about some uses of specific or important of specific liquids? We have water for bathing, cooking, drinking. Milk contains nutrients that keep our bones healthy. Honey boosts memory. I remember when we were younger, they would tell us take a lot of honey, and our parents used to buy honey for us because we used to believe that honey is good for memory and also important for our immune health. And petrol is used as fuel for combustion engines. So these are some few examples of liquids and how important they are to human lives. For our last state of matter, we'll be considering gases. So what is a gas? Any material that has no definite shape and no definite volume is a gas. No definite shape, no definite volume, a gas. Or no fixed shape, no fixed volume. And if you look at the trend, how we are moving, if you talk about the properties of gases, definitely you've gotten the first two already. Gases have no fixed volume. And they also do not have fixed shape. If you look at the diagram you have on the screen, the gas is that fume coming out from the factory. These are gases, and they do not have a particular volume. Why do we say they do not have a particular volume? You can see that they just spread to occupy the space that they have. So the first 2 points are linked. Gases just spread to occupy the available space. You can't really tell. So if you have a particular container, like those of us who have cylinders that will go and fill to cook, the gas that you are given, the amount that you buy will fill the space that you have. So that's one interesting thing about gas. They do not have fixed volume and they do not have fixed shape. But one interesting difference between gas, solid, and liquid is that gases can be easily compressed. You can think of balloons. Fill it with gas and try to compress it. See, it's easier to compress compared to solid and liquid. And then gases also spread to fill their containers. And then particles are far apart and move freely. From this diagram, you can see that the gas particles just have a lot of space, freedom to move around. That's one interesting property of gases. Importance of gases. For the importance of gases, I've just given oxygen is used or needed for breathing, and carbon dioxide is used by plants to make food. And these are some few examples of gases: oxygen, carbon dioxide, and water vapor. So far so good. We've come very far, yes, in understanding the basis of materials, matter, classifications of matter, and some examples of each and properties of each. And I'm sure you must understand everything we've discussed so far. So let's pick some past questions to revise what you've learned so far. So for the first question, we have which of the following is not matter? Which of the following is not matter? And for that, we have ice block, air, light, and smoke. This is a past question 92, question 31. What do you think is the answer? The answer is light. Why do we say light is the answer? You see, light is not considered matter because it has no mass and does not occupy space. It is just a form of energy. So light is a form of energy, not a state of matter. For the next question, which of the following properties is or are common to both liquid and gases? If you look at the definitions of liquid and gases that we have, which of these four options you think is common to liquid and gases? And the answer is both of them do not have definite shape. Both of them do not have definite shape. And interestingly, liquids have definite or fixed volume, but they do not have definite shape. And gases do not have both definite shape and definite volume. That's interesting. So they do not have definite shape, they do not have definite volume. Liquids have definite volume, but they don't have definite shape. But solids have both definite shape and volume. So the only common thing between liquid and gas is their shape is not definite. They take the shape of the space they find themselves in. And this was a 97 question, objective question number 17. And then for the next one, 1998, question 8. Gases are more compressible than solids. Gases are more compressible than solids. Why? What do you think is the answer? Which of them? Good. There are wider spaces between gas molecules. There are wider spaces between gas molecules. So if you look at the particle diagram that I showed you earlier, you see that the spaces between the gas particles are wider when compared to that of solids. Then in 2000, question number 3, which of the following statements about states of matter is correct? Which of the following statements about states of matter is correct? What is the answer? Good. So molecules in a gas move faster than those in a liquid. Molecules in a gas move faster than those in a liquid. That is the answer. For our next question, just recently, 2025, question 5. Which of the following substances has a definition? This is a bonus question. Which of the following substances has a definition? In simple terms, they're asking which of the following substances is a solid. That's what they're asking. And out of these 4 options, the only solid is stone. And even if you didn't understand this question, one interesting thing about answering objective test question is this. You have 4 options. And out of these 4, kerosene and water are liquids. So these two are too similar. They are from the same state of matter. So they can never be the answer. So you have to choose between air and stone. And only stone has what? Definite shape. 2025, question 5. You see how easy some of the BECE objective test questions can be. So all you need is proper preparation and subscribing to this channel so that it will guide you through and make you a scholar. Good. So this is the only solid in the options given. Okay. For the next question, which of the following statements best explain why gases are more compressible than solids? And the answer is particles in gases have wider intermolecular spaces as compared to solids. That's why they are more compressible. So you see the particle diagram of gases, the particles are widely spaced, but for solid they are very close. So compressing solid is much more difficult, but compressing liquid gases so easy. So pay attention to this particular question. This is a multiple choice question. But look at this. In 2003, this particular question came in question 4C. Explain why gases are more compressible than solids. Explain why gases are more compressible than solids. And the answer is the particles or molecules of gases are far apart, whereas in solids, they are more compact. Now look at this. You see how similar this question is to this particular question? So this came as section A question, but this section A question was restructured as a section B question from 2003. That is, the particles or molecules of gas are far apart, whereas in solids, the particles are more compact. And you can see that from the diagram. Solid, the particles are close. Gases, they are wide apart. And take note of this. 2006 question 4CI. State 2 properties that are common to all states of matter. State 2 properties that are common to all states of matter. This is a section B question. Section B. 2006 question 4CI. State 2 properties that are common to all states of matter. And the 2 properties are matter occupies space or has volume, and matter has weight or mass. And note, This question was restructured into objective questions. So this question, 2006 section B question, was actually 1992 question 1 and 2007 question 1. All of these were objective questions. So objective question just repurposed into section B question. So pay close attention to this. As you are preparing for a final year exam, questions can be restructured and there's nothing new on it. Yes, let me just put it that way. There's no question you made that you think, wow, this is fresh from somewhere from space. No, it's still from your textbook, and past questions that have been repurposed to look new. For this question, this is an assignment for you. State three difference between molecules in a solid state and a liquid state. And then 2007, make the sketch to show the arrangement of the particles in each of the three states of matter. You can find these answers in 2007 BECE question 2C and question 2A 2002. So if you do not have the past question, you can get any appropriate one of your choice and check to find answers to these questions. So thank you so much for learning with us. This is Learner's Aid. Please subscribe to the channel so that you didn't miss any interesting future lessons that will train you into our future scholar. See you in our next lesson.